Now imagine that an array is given and array is visualized as, so we can see that array as a complete binary tree. Now what we want to do is we want to define certain formulas, and let's say the formula we want to define is, first one is given the parent index. Now imagine the index of 7 is given to you. We want to tell what will be the index of its left child. Like for 4 the index is 9. So we have to define a formula. If parent index is given, pi stands for parent index here, how do we calculate the left child index? Same way, we want to know if parent index is given, can we come up with a formula which can say a right child will always be at this particular index. So we need to come up with this formula. And same with the reverse also. So if you are given a child index, let's say if I give you index of 7 4, our answer should be the parent of 4 is 1. So we have to go the other way. For any given index in this array, we have to tell who will be the left child, who will be the right child, or who will be the parent of that. So these three formula we want to define. So let's say how do we derive these formulas. So let's say if index given is 1, we want to figure out the left child of 1. So if we see the left child of 1 is coming out to be 3, same way right child of 1 is coming out to be 4. And if you look at it, 2 left child is 5, which is, if we say double of 2 will be 4, and we are adding 1 to it. So if we say 2 into 2 plus 1 is giving us the left child probably, and if we go right we say 2 into 2 will be 4, and we add 2 to it. So we are, just guessing the formula may be, let's double up this value and add 1 to it for left child, double up this value and add 2 to it and form the right child. So let's look whether this formula is holding good for other children also. So for 3, the left child is 3 into 2, 6 plus 1, 7. So what we are saying is that left child formula for anything is 2 into parent index plus 1. So parent index, if it is 3, 3 into 2 plus 1 is 7, and 2 into parent index plus 2 is the right child. So these two formulas we have validated here, they hold good. Let's validate for 0 also. Now 2 into 0 plus 1 gives us 1, that is the left child of 0, and 2 into 0 plus 2 gives us 2, the right child of 2. So makes sense, these formulas look good, that they are the right formulas for finding left child and right child if the parent index is given. Now third thing, I want to give you some time for doing this exercise. Can you derive this formula? If you are given an index like 8, you have to tell who the parent for 8 is. So our answer should come as 3. Same way, if I give you index 7, you have to tell what will be the parent index for 7. And now remember, for 7 and 8, for 2 children, the answer should be same. You can think about it, you can kind of use these formulas. Pause the video, spend some time and think about it yourself. Can you come yourself with a formula for what is the parent index for given child index Ci? Well, I think you have spent some time and you have your answer ready. So now let's look at, from 7 we want to get 3, and from 8 we want to get 3 as well. So previously we multiplied with 2, let's try to divide by 2. So 7 division by 2, if you see, this is integral division, integer divided by integer. So 2 3 the 6, it will give us answer 3. So for left child, answer is coming valid, that if we divide left child by 2, the answer is coming out to be the parent. Now 8 divided by 2, because we are dividing by 2, the answer is coming out to be 4. But this is not the right answer, because for 8 the parent is 3, not 4. Now what we can do is, we can say let's subtract 1 from both of them. So 8 minus 1 will become 7, 7 divided by 2 will be 3, and 7 minus 1 will become 6, 6 divided by 2 will also be 3. So why not define this formula like Ci minus 1 divided by 2, that will give us the parent for any given node. So if you look at the parent of this, it will be 1 minus 1 divided by 2, so 1 minus 1 will be 0, 0 divided by 2 will be 0. Same way 2 minus 1 divided by 2, so 2 minus 1, if we write 2 minus 1, which is 1 divided by 2. So if you divide 1 by 2, then eventually what will happen is the answer will come as integral answer, and 1 divided by 2, ideally it is 0.5, but in computers if you divide integer by an integer, the answer always comes as integer, not a decimal value. So it will come out to be 0. So this looks good, that we are able to define three formulas: left child of any parent, right child of any parent, and the index of parent if we are given the child index. Well, so if you have understood things till now, then you will understand like binary heaps, or heaps are very easy to understand.